and welcome to Mike's Development Zone. Today we're going to look at template method design pattern using a football game example. The template method pattern is useful when you have a fixed sequence of steps that must always be executed in the same order. You want different implementations for some steps. You want to avoid duplicating code for the same workflow. In our example, every football match has the same phases. Start the match, play the match, end the match. But teams can implement these steps differently. The template method pattern lets us enforce the sequence while allowing custom behavior for each team. The template method pattern is useful when you have a fixed sequence of steps that must always be executed in the same order. You want different implementations for some steps. You want to avoid duplicating code for the same workflow. In our example, every football match has the same phases. Start the match, play the match, end the match. But teams can implement these steps differently. The template method pattern lets us enforce the sequence while allowing custom behavior for each team. Subclass declaration. Barcelona game extends football game, so it inherits the play. Template method. Start match. Implementation. Prints Barcelona starts with possession play. Defines how this team begins the match. Play match. Implementation. Prints Barcelona keeps the ball and passes frequently. Shows the team's playing style during the game. End match. Implementation. Prints Barcelona ends with controlled play. Defines how the match ends for this team. Observation. The algorithm order is fixed by the base class, but the behavior is unique to Barcelona. Reviewing the subclass declaration. Bayern Munich game also extends football game. Inherits the play. Template method. Looking at start match. Method implementation. It prints Bayern starts with high pressure. Different from Barcelona. Shows Bayern's aggressive starting style. Viewing play match. Method implementation. It prints Bayern plays fast and attacks immediately. Subclass decides how the match progresses. Looking at end match. Method implementation. It prints Bayern ends with strong intensity. Defines how this team finishes the game. Our observation. Both subclasses use the same template method, but the behavior for each step differs. The template method ensures consistency in workflow. We create two objects, Barcelona game and Bayern Munich game. Call play on each object. This executes the template method in the base class. It calls the three steps in the correct order: start match, play match, end match. Each subclass's overridden methods determine the actual behavior. Output differs between the teams, but the sequence is always guaranteed. The console output you can expect is shown below. An empty line separates the results of the Barcelona and Bayern games. The first three lines show Barcelona's steps, and the next three lines show Bayern's steps. The template method ensures that the steps run in the correct order, while each subclass defines the behavior of its own steps. The template method pattern is ideal when you have a process that always follows the same sequence of steps, but certain steps need to behave differently depending on the subclass. By defining the overall workflow in a base class, you can ensure that the steps always run in the correct order, while allowing subclasses to customize specific behavior. The template method pattern is useful when you have a clear abstraction that defines the overall structure of an algorithm. For example, imagine an animal class that represents the concept of an animal, with subclasses like fish, cat, and dog. The animal class defines the skeleton of actions, while each subclass customizes its specific behavior. This ensures a consistent workflow across all animals. It also makes maintenance easier. If the shared behavior in animal changes, all subclasses automatically follow the updated structure, while still allowing each animal to override only the steps it needs. In short, it's powerful when you have a well-defined abstraction that all subclasses share. The template method defines the overall structure of an algorithm, while allowing subclasses to implement the specific steps. It ensures that the workflow remains consistent, yet flexible enough for custom behavior. This approach helps reduce duplicate code and makes workflows easier to maintain. The football example demonstrates how the same algorithm produces different results depending on the subclass. Thanks for watching. If you found this explanation helpful and want more content on programming and design patterns, make sure to subscribe and turn on notifications so that you don't miss future videos.